Welcome all, it's Russ, and I'm here to answer a question that someone posted as a response to one of my YouTube videos, and that is, what's the difference between cloning and forking a repository in Git? Now, it's an excellent question because at some sort of an abstract high level, it feels like cloning and forking are the same thing. Cloning is taking a repository and making a copy of it someplace else. Forking is taking a repository and making a copy of it. So if they're both making copies, what's the difference between the two? Well, the interesting thing is that down deep in the guts of Git, cloning and forking are actually very similar operations. Now, if you're a true master user of Git and you understand how it works all the way down at the level of the SHA hashes and the commits and all of that, then you understand that fork and clone are not the same thing. But they do have a surprising amount of overlap. So if they are at an abstract level very similar, and at a gut level they're very similar, why do we even have two options? Well, what happens here is that at the practical level of the people who use Git in a day-to-day basis, clone and fork are very different operations. Let me explain why. First of all, let's talk about what a Git repository looks like. All right, so I'm going to imagine that we have a repository here. Now, a repository is actually made up of thousands of different files. But let's just draw some symbols to abstractly represent some files that have been put into this repository at some point in time. Now, if you want to clone this repository, all you do is that you create a new repository someplace else, which has the exact same files. And so everything that was in the original repository is now present in another repository. Now, it's conventional when you do that you're also going to extract these files out, although it's not technically the same operation, but you are technically going to create a file system that says, I've got my food directory, and there's a file called bar inside of it. I've got fred/1.x, whatever it is. I've got a whole bunch of different files. But a clone is not creating the files fundamentally. A clone is duplicating the repository. It's just conventional that we'll also extract at the same time. All right, so if we ignore the repository for the most part, and we just think about the process of cloning itself, what we've now done is we've created an exact replica of the original repository that's on our own computer. So we can actually break the connection between these two. And we can make changes into our local working copy. And then we can do a commit. A commit is something that says, these changes that I've made are something that I want to remember for the future. And so you're committing into your local repository, and this creates new entries. Now, one of the things that's very important to understand about Git, if you want to understand at the gut level here, is that Git never destroys old files. Little asterisks, if you know about branches, and if you have a dead-end branch that never gets integrated into master, that can get garbage collected. But in terms of the main line, the way Git works basically is that it remembers all the things that have happened previously, and then it adds new things to it as well. So Git doesn't so much change the state of the system as it does add additional things to it. So this repository, as it exists right now, has these three changes. It's a little bit more advanced than the old repository. Now, the question is, how do we communicate these changes to the central repository so that other people can see it? We'll get to that in a Git push in just a moment. All right, so why do we create this clone? Well, older version control systems didn't have this local copy. And so what happened was, anytime that you wanted to make a change, instead of it doing a commit to a local copy here, you always had to do a commit to the central server. And if you had any sort of a network problem, or we'll get to permissions in a little bit here, if you had some sort of a permissions issue where you weren't authorized to write into the central repository, then you might not be able to save your changes. The cool thing about the local repository that you have in Git, see, this represents your computer, this represents a central server, is that you can save things onto your local computer. Now you can continue to make changes. And so you can build up a history on your local computer, keeping track of changes that you've made over a series of hours or even a series of days. Now obviously, if this computer goes away entirely, if you just, the hard drive crashes and it's gone, you've lost this. But as long as your hard drive hasn't crashed, you can now build up a history that says, I've been working on this feature for 2 weeks, and here's all the changes that I've made over time during this 2 weeks. And if I want to go back in time to look at something old, I can go look at what I had checked into my copy of the repository 6 days ago. It's a pretty cool feature. One of the things that this does is it allows easy collaboration. Because now let's imagine that there's another developer writing their own code. They want to do it on their own computer. And so we're going to make another clone here. Now it's making a clone off the master repository. Now where does this come from? Git is actually a very flexible system. The tool itself is very flexible. You don't have to have a central server exactly. But for most of us, conventionally, what happens is that we do have a central server, and the most common place to put it is on GitHub. And so GitHub is kind of representing the joint knowledge of all the developers who have worked over time making changes into the system. So far what we have is we've got a central repository. We've got 2 clones of it. And so one of the clones has been updated. There's new things that have happened within it. And one of them is still a pristine copy. How are we going to get these all to interact? Well, the way you interact here, first of all, before we talk about pulls and pushes, let's make another change. Let's assume again that this developer has made his own changes, his or her own changes, and has created some new file. Now this is kind of our worst case scenario here, because we've got a central repository that has the oldest version of the code. We have 2 different diverging copies of the code with different changes that have been made inside them. This, in the sense of older version control systems, this would be disaster. I mean, things like Subversion. Subversion is what I use for my own personal home directory storage. It has some ability to merge these sorts of diverging changes, but it's not easy. Git makes this relatively easy. All right, so how do we get things into the central server? Well, what's going to happen here is that as you've been making commits to your repository, you will from time to time do what's called a push. Now what a push does is that a push takes whatever has changed and moves it up into the other server. See, this is where the central server becomes important. In theory, Git could have anybody sending changes to anybody. But in practice, what we generally do is that we have this central hub of all the communication, and so our pushes and pulls go to this central server. What a push does is it basically does a comparison between these 2 histories. And it notices that there's new information that's known on this new local repository that's not known to the central repository. So this will get copied over. And now what this means is that the central repository is synced up with the other one. Now, what's the next thing that could happen? Well, let's imagine that we try to push here out of that first copy. You notice that we didn't have to push in the same order that the changes were made. We push whenever we feel like there are changes to be done. In this case, ideally what we want to do is we want to send this update up to the server and have some new server state that's the mix of the two. Occasionally you can do this, but generally this is going to get rejected. And what's happening here is that we're going to notice that there's new information that exists inside the server that we didn't know about yet. And so this gets canceled when it first is attempted. Instead, what it says is that you have to sync up with the server. So what we're going to do here is we're going to do a pull. Here's a pull operation here. And a pull is exactly like a push, except that the pull goes up to the server and asks the server, do you have new information that I need to know about? Well, it does, and so this gets brought in. Now, what we do have is that we've got these two different changes now that are known to this copy of the repository. So far, it's the only repository that knows that there are these two changes. What are we going to do? In some cases, Git can solve this automatically with something called a merge. A merge is something that basically says, okay, I'm going to take these two things, I'm going to figure out how they work well together, and then let's create, what's one more symbol? We'll do a diamond here. We'll create one more record. And this record is the record that says, here's the information about how we mix the star and the square together into one unified system. Sometimes creating this merge is something you have to do manually. Sometimes it's something the system can do automatically. But generally, this is what's going to happen. We're going to pull in these changes, create a merge between them, and now what we have is a repository that reflects everything that's in the central server and also reflects new things as well. So now we're going to retry our push, but now it works because this side already knew everything that was in the central server, and so we just add the objects that represent new changes. And now the central server has what was in this computer's system. Eventually, when we do a pull over here, then all these changes will be copied in. So this is a very, very nice way of allowing a whole bunch of developers to work in parallel on code that might have some commonalities and maybe it might not, and commit their changes up to a central server periodically, communicate those changes back into their own computers as whenever they have time to do so. All right, so this is what cloning looks like. Cloning is creating something that's specifically designed to have an automatic system for pushing back into the central server. So why not use cloning for everything? Well, what if this is very important? What if this central repository is something that people care a lot about? Or frankly, what if you're just out on the internet and you want to make sure that you don't have somebody who has evil intent who might clone your repository and push changes back? Well, obviously what you're going to want is you're going to want some sort of permission control. Something that allows you to say this user is allowed to access it and this one is not. Now, I haven't ever worked with permission control myself at the Git level. I've only done it on GitHub. But GitHub has the concept of a owner of a repository and collaborators. So the owner of the repository is the person who created it, and the collaborators are the people who are trusted to make changes. And so you have to add collaborators manually because obviously you don't want to have some sort of automated process that could allow some evil person to get access. So what's going to happen here is that for most people, they're not going to have rights to perform a push. Now, if this is a public repository, they can still clone it. They can work on it. They can make their own local changes, but they're not going to be able to push. So why would someone work on something if they don't have the permission to commit to it? Well, this is a classic thing that happens very often in open source. In open source systems, you might have something like this might be the Linux kernel, or it might be OpenOffice or Apache or some other project that has a central repository of code. It's critically important that we keep that code correct. We have people who are responsible for controlling what goes into this code, and yet we want to be able to encourage people out there to be able to make their contributions. All right, well, how do we encourage them to make their contributions? Well, one of the things that you can do is that if you don't have permission to push, you can send an email to someone. You can send an email that basically says, hey, I have something of interest. This is code you might want to have. So let's go back in time here. Let's just do this. We'll go all the way back in time. So now we've got a central repository that's important, and we've got somebody here who is untrusted. Now, untrusted doesn't mean evil. It just means anonymous. Who knows where it comes from? Who knows whether they've got anything of use? I mean, this might be an evil hacker. It might be a highly experienced contributor. Untrusted just means I don't know this person. But they may have made changes, and so what you might do is that you could send an email. So you could write an email to someone that says, hey, listen to me. I want you to go look at these changes I've made because I think these are really interesting, and I would like you to put my changes into the central server. I don't have authority to put them into the central server, but you do. Would you mind bringing these up? And Git is kind of cool because if the person who's the administrator, if the administrator has the ability to go and to look at your code, that's my attempt at little eyeballs. I think it was terrible. But if they look at your code and they say, oh, this is great stuff. All right, yes, I'd like to bring it in. Well, the administrator can pull it in, and now it becomes part of the central repository. Congratulations, you've just contributed to an open source project. You've made the world better. Question is, how does the administrator access this repository? This repository is probably sitting on your personal computer. So what do? Well, in the olden days, what you actually would do is that you'd attach a file here as part of the email that said, here's my changes. And that works as long as the changes aren't too outrageously gigantic. You could do that. In that case, they don't technically copy out of your repository. They just take the file and make identical changes into the central server. But it would be nice if we could integrate all of this into the whole Git system, because we've got this pull and push mechanism. It seems like it would be a pretty good thing. Well, what can we do? Well, for that, what we can do is we can do a fork. All right? So let's go back in time again. And now We've got our same central repository. Central repository here that contains critical information that we don't want anybody to adversely affect. But now we want to make our own changes to it. We'd like to make changes in a copy of the repository that's publicly available, but that we have complete control over. All right? So let's do a fork. All right. I need to make this smaller or I'm going to run out of space here. So here's your fork. Again, you notice that we've just made a duplicate of the repository. But here's the trick here. I don't know, maybe it's possible to fork onto your own private computer. I've never thought about that. But generally what would happen is that this is all on the central server. GitHub or whatever central server you happen to be using. And so what's going on here is that you now have a new repository. So this is the famous one. And this one is mine. These are related to each other, okay? So I've made a duplicate of the repository. But since I own this one, only I have rights to make changes in this copy of the repository, or in this repository. Now what I can do is I can do a clone. Now I can do a clone onto my personal computer here. So we actually have 3 copies of the repository at the same time. I know that sounds strange, but it works. So what happens here is that we can make our changes. Let's go ahead and make that change that we wanted to do. We want to do a push. We are authorized to do a push because we have control of this repository. And now what we have is out on the central server, we have a repository, not the famous repository, but we have a repository that has new updates. Now what we would like to do is we'd like to notify whoever's the administrator of the famous repository that I have changes that they might find interesting. And so I'm not sure actually if what I'm about to tell you is a feature of how GitHub works or if it's actually built into the Git software itself. But wherever it actually comes from, this is how it basically works. We know that this was a fork of that original repository. And so what we can do is that we can send not a push operation, but what's called a pull request. A pull request is something that gets sent from an untrusted server, or from an untrusted administrator, to the administrator of the well-known trusted repository. And the pull request says, I have a fork of your repo. In that fork, I've made some changes which I think you might want to put into the central server. So now this shows up as an email. It also shows up in the GUI on GitHub where you say, here's pending pull requests. The administrator of this repository can look at these changes, make a decision about whether they think it's a good set of changes or not. If they like those changes, they can actually initiate a pull. A pull is a lot like pulling from the central server down into my clone. You're saying that server over there at a distance has information that I would like to have in my local copy. Well, you can initiate a pull in the central server that targets this fork. And when you pull, you now bring it into the central server. And so this fork mechanism means that now you have multiple repositories sitting on the central server which have different administrative boundaries, On one of them, you have complete control, and so you can make your own changes. On the other hand, this is the well-known famous thing that might be interested in your changes. So, what's the difference between fork and clone? Remember that I said that fork and clone both seem conceptually similar in that they're both making copies of the repository. And I said that down in the guts, fork and clone are actually pretty similar because what they're doing is they're taking all of the commits that have occurred over time and copying them into a new location. What's the key difference between fork and clone? Clone creates a new repository with the same admin. Now, I'm not saying that these are the only changes, but this is the central change of why you would do things. If you want to contribute to the project as it currently exists, if you perhaps are trusted, so this is particularly for trusted users. Somebody has allowed you access to collaborate on the project. You can clone the project and then just push new changes as you go. Where you fork is when you need to create a new administrative boundary. You don't have rights to change this repository. And so you have to create a new repository where you do have rights. This is untrusted users. So the untrusted users were not trusted to access the central repository. So they created a new place of their own where they would be the trusted user. What are the mechanisms that you use in order to update them? On a clone, you just do a push. You push from your local computer up into the central repository. If you have a fork, you don't have rights to push into the original repository. Instead, you're going to make pull requests. You're going to notify the administrator that there's something you think that they will find interesting. And you ask them to bring things in because you don't have the authority to do it yourself. All right, well, I hope that was useful. I hope it was interesting. And I'll see you around later. Bye-bye.